to implement IPv6 at an operator's network with a focus on the subnetting and or rather how to plan your IP address within your network. So without any further ado, I'd like to give this opportunity to Tamon, who will be making the presentation. So Tamon, over to you. I think you're on as Ashok, no? Kevin, are you able to see Tamon?
Can you hear me?
Kevin, can you see Tamon? I can't see him. So can you try and hand over the presenter icon to Tamon? Kevin? Okay, so just give us a moment as we try to get on someone on to do the presentation, so it will probably just be a minute. So this is a question to the room. How many people are having an audio problem? How many people are having a problem hearing the audio? We could just post it on the chat room.
Oui, allô? Oui, bonjour. Oui, bien, merci vous. Oui.
Okay, so all right, there I see Mukom. Frank, could you? Sorry, not Frank. Kevin, could you move it? Could you hand over the ball to Mukom? I can see him online now.
Mitch, I'm waiting for you to hand over the ball to me.
Yeah, I've asked the host, who is Kevin, to hand over to you. Kevin? Okay. Come on, you should be good to go.
Yes. So, good afternoon, ladies and gentlemen, and welcome to this second webinar. My name is Mukom Akong Tamun, and I am the training manager at AFRINIC. So, in the next 10 to 15 minutes, I'm going to give us a short presentation on IPv6 address planning. And in it, I'll lay out the framework for how we should think about planning for IPv6 address space, how much we need to request from AFRINIC, and after you have your allocation from AFRINIC, how do you carve it up and assign it to different elements of your network? So the purpose of IPv6 address planning is, one, as an ISP, how much space do I need? That's one of the first questions that's going to go through your mind. And how much do I need to request from AFRINIC? Obviously, if you're going with globally routed addresses, you're going to have to request them from AFRINIC. And third, after you have your address space from AFRINIC, how do you carve it out to assign it to different links of your network? Now, globally, this diagram just shows us globally how the whole IPv6 address space is managed. There at the top, we have, you can begin from the top or the bottom. From the top, you have the IANA control space, which comes out of 2000::/3. Out of that, we have blocks that are given out to the RIRs. And out of what the RIRs have, we give to LIRs, which are ISPs, and the LIRs could give out to end sites. And these end sites have subnets, which you could not assign to what particular host subnets. So here is a conceptual overview of an ISP network. Now, I want to begin with the green boxes. The green boxes represent the layer 3 aggregation points. Now, for the ISP, it could be a POP. Most likely it's going to be a POP. That central aggregating point to which you connect lots of other customers. And then within a region is made up of an aggregation of sites, and the collection of your regions make up your ASN. So that's a conceptual overview of an ISP network, which we are going to use in this framework of IPv6 address planning. So before I go on, I would like to give a few clarifications. Quite often I see lots of examples of IP address planning in which people just go ahead and use the /32, assume that they have /32. It's important to know where this /32 comes from. Most RIR policies, including AFRINIC, set a /32 prefix as the minimum size that an ISP or an LIR can request from AFRINIC. Now, this does not mean that you should start out with /32 and try to fit your network into it. That's quite the wrong approach. Instead, you should analyze your needs and apply based on them. If you can show that you need /24 or the /20, I am very sure that AFRINIC is going to be able to give you that. Now, the second thing I also like to point out is that the RFCs essentially recommend that we use /64 for all subnets. Even P2P links and loopback addresses. There's a lot of contention on this point, but I'll say that while you are planning, follow these guidelines. Now, when it comes time to actually assigning things to links, you can go ahead and configure what makes operational sense, be it /127 or /128 or /126 or /120. Now, that kind of decision, when you are actually assigning stuff, you can go ahead and veer away from what the RFCs recommend. But while you're planning, do have in mind, allocate a /64 for all links. Also, try to ensure that all your prefixes fall on nibble boundaries. A nibble boundary is simply multiple of 4. And why the magic number 4? Because each of the characters in an IPv6 address space is made up of 4 bits. Once you work with nibble boundaries, your life is going to be a lot easier, as we'll see in a couple of slides. Also, the recommendation is to plan a hierarchical scheme so as to allow for aggregation. Now, initially, you would find that when you're doing some reading on IPv6 that one of the biggest hopes of IPv6 was that there was going to be aggregation, that all addresses will be aggregated, that end sites will get the address space from the LIRs and therefore would have smaller routing tables and all that. So while you are planning for your own network, it is important to try and think in terms of aggregation. If you go back to the diagram I displayed on the previous slides, you'll find that that hierarchy goes as follows. You have a collection of sites. That's the lowest level of the hierarchy. Now, a collection of these sites make up a
Come on. Hello? Come on, we can't hear you. Okay, looks like we've lost someone. Try and see what the problem is. What problem there? Please bear with us for a minute. Uh, Paul, Paul Muyu, if you can hear me. The system has automatically handed you over the round ball, if you can see it, the blue and green ball. Can you try and hand it over to me? Just click on it and drag it to my name. Drag it to Michuki Mongi. Paul Muyu. Mr. Paul Muyu, could you kindly hand over the round ball on the speakers list? You see next to your name you have a round ball. Could you try and drag it? Kevin, you can make host key? Oh, okay. Host key. You know, mm-hmm. 1, 2, 6. Okay. Okay. Right. I think since we are having a problem with Samon, I'm going to hand over the role to Frank Habich to sort of carry on, and when Samon gets back, we will continue with him. So Frank, I'm handing over this to you. Are you ready?
Yes, I'm ready.
Okay. Please proceed.
Okay. Thanks, everyone. I want to share my desktop. Sorry, this is the first time I'm sharing. Yes.
As Frank is preparing his desktop to share, the objective of the first session was to sort of go through a background of AFRINIC training material and their recommendation on how to do IPv6 address planning. So we'll skip that briefly. We'll go back to it. We'll have overview of what SimbaNet has done with respect to their IPv6 risk planning from an ISP's point of view. And later on, we'll have other presentations from John and I think Modu from Sonatel as well. So I'll start with, let Frank start. Go ahead.
Okay, hello everyone. Thanks, Michuki. I hope everybody can see my desktop, my presentation now. Is that right? Yes, I'm sharing my desktop. So IPv6, as everybody knows, we have a very large address space now, and we can somehow waste addresses or plan really long term. We don't have to plan for the next 2 years, we can plan for the next 10 or 20 years. And that is both for the ISP infrastructure and for customer assignments. And then hopefully we will have less work maybe in the future renumbering everything again because we assigned enough addresses to customers or to POPs in the first place. And with enough addresses, everybody, every device can have their own public IP address. We can have end-to-end communication between the devices. And one of the printers in my office here has an IP address similar to the one given at the bottom, but I swapped one bit in that address. So it's not really the correct address. About the history with SimbaNet, long before I joined in 2008, after the AFRINIC meeting in Nairobi, thanks to also initiatives by Jordi, my colleagues got an allocation from AFRINIC of that /32 block, and I made it my mission since I joined in 2009 to get it online and live. And since February 2010, the block is announced globally, and we basically have the global internet connection on V6 as well over a link with our upstreams that is dual stack, as it should be. By now we have two native upstreams that are dual stack, and since the address policies are not always the same, we actually note that they use different prefix lengths for the link between our upstream and us. So that is an interesting side note. But it's normal to get native IPv6 up on dual stack links from international players by now. So for preparing an addressing plan, I think I want to say that it's very important for everyone to understand the requirements, to understand the possibilities of the IPv6, and sorry, that is me. And see how they want to organize their IP addresses by POP. Somebody gives me an echo, but it's not me. Sorry. And as I did, I want to recommend that somebody sits down and drafts the plan, how it's organized, and then take some time to think about it. It took actually a lot of weeks that I had it in the back of my mind and was considering different things. And then you can share it with others and get some input. But in my opinion, it will be good to do it yourself, not just to copy and paste the whole addressing plan for IPv6, because then you will be able to explain to others and you know the reasons why you've done it. And of course, different aspects work into this, like the nature of your network. Now, different ranges should be defined for different users, one for the loopbacks, others for the core network links. Now, Mukom has mentioned /64 should be or can be planned for every link. That's not how we do it, but it's one thing that you hear very often. So which subnet size for each of the links do you decide to have? It also depends on the technology, because nowadays for serial links or SDH links, it is very useful to use a /127. If you plan to do any casted services like DNS servers or time servers that are from different locations and different machines answering on one certain address, you reserve addresses for that as well. And then for servers, data centers, and the biggest part will be IP ranges for the connectivity customers that are connected to your POPs. And then one question will be whether you aggregate per POP, so that in your internal routing for your ISP, you have only a supernet like a /40 or a /36 in your internal routing, or whether you allow those 65,000 blocks of /48 all to be aggregated, used anywhere, and have the internal BGP sorted out, which should also be no problem. So for our specific addressing, one of the first questions that I asked myself was, after first deciding that a loopback address should be a /128, because a loopback address doesn't talk to anything. It doesn't have any other devices on the link. That's why, in my opinion, it doesn't need a /64 reserved. It's only ever going to be a /128, a single IP address, which is the, of course, in IPv6, the equivalent of a /32 in IPv4. So every one loopback address on every device consumes one IPv6 address. So I was thinking whether it should be 65,000 or 4 billion. And because we have enough addresses, I decided for the 4 billion. So it's a /96 reserved for loopback addresses, not just a /112. But now I know that it's too conservative. We should really give a /64 for the set of all the loopback addresses for all the devices in your network, in my opinion. But that one is reserved anyway, in this case. Another question that people would have to ask, what prefix length would be used for the core network links in between the POPs, internally between different routers of core routers and aggregation routers and all that. Now in our case for Symbanet, our internal links are all Ethernet based, so we don't have serial or SDH links for which /127 is recommended. And we've decided to use a /112 for each link, which is again very conservative. And to make host scanning more difficult, much more difficult, I've decided not to number them ending with 0 and with 1 or 1 and 2, but to use random host addresses in the last 16 bits of these IP addresses. Because as mentioned by Mukom, others say both in discussions and in the RFCs that the /64 should be reserved for everything. Then another consideration for the overall addressing plan is the size of blocks to be assigned to customers. Will you decide for one size fits for every customer? What size do you give for co-location customers? I don't want to give the answers here, I just want to mention the questions. Small offices, home offices, what kind of blocks do they need? In Europe, many tend towards a /56 instead of a /48, but bigger customers should get a /48. And what size of block will mobile customers get? One thought could be that anybody who gets a certain number of IP addresses or blocks like a /29 or bigger in IPv4 would then also qualify for a /48. That's a thought, but so far we have actually given IPv6 connectivity to very few customers, and those were all a /48 because they were really big. And then server networks, it depends on the data center structure. If you have many VLAN subnets, you will have a different subnet for each VLAN. What the size is to be, in my opinion, again very conservative. 65,000 hosts on a subnet are very much, and then a /112 would be enough. But if the staff is more comfortable with having /64, then one of the main arguments is again, which subnet size will cause the least confusion in your support team or NOC team. I think that should be important. Then the considerations for which IP addresses to use where. I think some IP addresses will be typed very often, and these should be kept simple, like having a 1 or a 0 in between the columns of the IPv6 address. These could be DNS servers if they need to be statically configured in the customer's machines or servers, or even just in the customer's routers to be given out automatically by DHCP-v6 or another technology. Then another consideration would be, do you want to block in your network border incoming traffic to all your core network addresses, all your loopbacks, so that nobody from outside who doesn't have any business with you can directly attack your servers, your routers and your infrastructure? If that's the case, then those kinds of addresses should be put close together into one supernet, and then it will be only one line in an access list for that supernet that can block all that traffic. And then, because I don't have any other examples, you have to fill in any other business needs, whatever comes up. If it's a mainly mobile operator looking to implement IPv6, I'm sure there will be very different considerations. So the result that we have here is that the first site that was IPv6 enabled was my home, and then afterwards the Symbanet offices are on native IPv6 throughout. And it's important to eat your own dog food, as they say, so that you get accustomed to the technology, that you find your own problems very quickly, and basically see how it works firsthand. And at Symbanet, a few of our customers are enabled, including our CCTLD and the regulator for the communication sector in Tanzania, and also the electricity company, for instance. Few of our servers are fully mated to IPv6, including an authoritative DNS server that is listed as with a Quad A record as having the IPv6 connectivity, and it's being used as such. And of course, at the moment we have more clients to do, to be convinced to implement it, and then get their understanding and security policies right, so that they can be happy IPv6 users. These are my contacts, and at the bottom I have mentioned a website that I like very much. It shows which popular domains have IPv6 enabled on web servers, email servers, and DNS servers, and there's a listing for every country. So this one is the example for TZ. And once everything is working, then you can see that when you log into a server, the last login was from some IPv6 address. That is obviously the IP address of my laptop here, because it was logged into that machine before. And then I just did a quick check There are actually at the moment 5 LIRs in AFRINIC that have gotten allocations of bigger blocks than /32. So if you have a plan to use more than a /32 and you can explain it to AFRINIC, you will get more. So this should not be a problem. And from one of our servers, just as an example, a traceroute here. So all IPv6 all the way to Seattle. And I think I've now finished everything. Hello? Yes, here's my. Okay. I hand over
Right. Are
to.
you finished?
Yes. Yes, I'm finished.
Thanks very much, Frank. So we'll leave the questions for the end of the session. And so right now, I've seen Mon is back, and we'll try and hand this over to Mon. Who will continue from where he left.
Can you hear me?
Yes, can hear you.
Hear me?
Yes, you can proceed, Mon.
About that, gentlemen, I lost my connection and I was not aware of it. So I'm going to continue from where I stopped. Mitch, was that where I stopped? Mitch? Mitch, can you hear me?
Sorry, I was muted. So please go to the next slide. I think this is where you are. Just one more slide ahead. Let me see. Yes, this is where you are.
Okay. So I'm just going to try and go quickly through this because most of what I had here, Frank has already given you in some detail. But some recommendations for planning is that you should try as much as possible to work with nibble boundaries, just because it makes life a lot easier. You should also plan hierarchical addressing at every single point. And which means that if you go along with the conceptual overview of an ISP network that I showed you, you begin with sites at the lowest aggregation point, and there's a couple of sites that make up a region, and a couple of regions make up your autonomous number system. And unlike in IPv4, where you're trying to economize space and do variable length, prefix length, in different prefix lengths to different subnets and networks. You don't do that in IPv6. Try as much as possible, at least within the same hierarchy, the same level of the hierarchy, use the same prefix length. That will be the equivalent of your SIM length subnet masking in IPv4. So, how do you go about estimating the needs of sites? The very first thing I would say is select your largest site and use it as a model for all of your sites. Yeah, obviously, there's going to be a case where if your largest site is way much bigger than is representative of your other sites, then you could choose say the smaller size, and then you assign 2 contiguous blocks to the larger site. But this is how you proceed. You estimate the number of N networks in the site right now, and a good estimate for that would be how many customers connect to that site. The site in this case to be a POP. How many customers connect to it now? And what are the growth projections to 5 years? And then you round that up to nibble boundaries. If you the estimate, in order to make sure that you fall cleanly on nibble boundaries, round up your estimate to 2 to the n, where n is a multiple of 4. So you have like 16, 256, 496, 65. The numbers look large, but believe me, once you bring down everything to the nibble boundaries, it's going to fall cleanly. Now, just as an example to show you the importance of working with nibble boundaries, if you consider that example, that 2001 ZVA 3C00:/40. Now 40 is nibble boundary aligned, and you can see that the first address and the last address in that range, the only thing that differs between them is that in the part of the address that changes, that is above the /40, is the hexadecimal digits will change from 0 to F. 0 to F are the top and the bottom and the top respectively of the hexadecimal digit range. So this is quite intuitive. So once you are working with nibble boundaries, you always know that the differentiating hexadecimal digits will always change from 0 to F. That's quite easy. Now, if you consider the second example of a /42, /42 is not nibble boundary aligned. You'll find that the first and last address, the change from 0 to F, except the defining hexadecimal digit, which differentiates the network part of the address versus the subnet and host part of the address. It changes from 0 to 3. I've put it there in blue. Now, this is not intuitive. Unless you are really a mathematical whiz, it's not easy to know what the last hexadecimal digit of that range is, unless you calculate it either manually or using SIPCalc. So that's one important reason why you should work with nibble aligned boundaries. So next thing we want to do is to find the total number of n prefixes required. An n prefix is being defined here as that prefix which you give to the network. Frank was talking about it. That has to be what you decide as an ISP. Are you giving /48 for all customers, or /52s, or /56s, or /60s? But again, for purposes of planning, it's better to go with the highest possible noun, and then once you're actually assigning, you do something else. So I'll say, now estimate the total number of sites in your largest region. I mean, you know that, and round it up to the nibble boundary. Largest number of sites is simply what? How many POPs do you have? That's your that's because in the case of an ISP, the site will be, say, a POP for an ISP. And then you calculate the total number of n prefixes, which is simply you have the maximum number of n networks per site multiplied by the number of sites multiplied by the number of regions. That gives you some number called n, which is the total number of n site prefixes across your entire ASN. You know that it's across your entire ASN because you're taking the regions times the sites. Next, now you have n number of n sites, but how many subnets does this represent? How many subnets are required to give you that number of n sites? The simple formula you use to find that is the logarithm of n divided by the logarithm of 2, and you round it up to the nearest integer. Now, the last and important question is, which is what we are trying to get to, is what size should you request from AFRINIC? Now, first of all, that what size you request from AFRINIC is going to depend on what you decide that you're going to give each of the customers that are connecting to your POP. Now, if you are choosing to go with /48, you take 48 divided by, minus s. Or if you're choosing to do /52, you take 52 minus s. So whatever site you decided as policy you're going to assign to your customers, you subtract S from it, and that will give you the prefix size that you're going to request from AFRINIC. Here's a quick worked example just to illustrate the steps we just. Now, an ISP has operations in 10 provinces. The largest province has 50 POPs, the largest of which has about 2,700 clients. Estimate the IPv6 addressing needs of it. So, our initial analysis, what we do know, we know that the number of regions is close to 10. If I round that up to nibble, so that you're going to fall around nibble boundaries, I have 16. The number of sites is 50, which I can round up to 256, and the maximum site size is 2,700, which I can easily round up to 4,096. Now, I calculate the total number of N network prefixes, which is simply I multiply my number of regions by the number of sites times the number of times the maximum site size, which is 16 times 256 times 4,096, and I have that number 16,777,216. This represents 24 bits, which is simply the logarithm of that 16 million, 16.7 million, all over logarithm of 2, which is 24 bits. Now, assuming if you're going to be giving /48 to each of your customers, you take 48 minus 24, and the answer is 24. Therefore, you request a /24 from AFRINIC. If, however, you choose that you want to only give /52s to your end site, then /52 minus 24 is 28, and therefore you request a /28 from AFRINIC. And of course, just note that the AFRINIC policy state that the longest prefix that you can request as an LIR is a /32. So some recommendations for carving this out, which you must have already had Frank go through. Assign at least one /64 per individual network segment. Now, in Frank's example, he has say /112 in some places. But here's the thing: if you assign /64 and then use a /112 out of it, configure what makes operational sense, so that if in the future you have problems, you can always revert to the /64 without having to do some painful renumbering around. Ensure that all prefixes fall on nibble boundaries. Assign at least one /48 per site, and do not forget that even though you are planning for the customers that are connected, you need to also give space for your infrastructure, your own infrastructure. So it's a good idea to reserve one /48 per region for infrastructure needs, and pick your loopback and inter-device links from there. And again, configure what makes operational sense. So thank you very much. Questions, comments?
Thank you very much, Tamon. So I think what we'll do is I will request everybody to hold their questions until we are done with the slides, and then we can do the Q&A session. So next up is John Gitao, who has to swap one to another. John, are you there? Okay, so in the meantime, so thanks, Tamon. I'm going to take the role away from you so that I can load up the presentation. from John, who is next. Okay, presentation is up. Let's see if John is back online. Okay, looks like John is not on. Modu, would you be able to share your screen and proceed as we, then maybe you can have John make his presentation after you.
Hello?
Oh, yes.
Yeah, I sent the presentation to Isham. Can he put it on the screen for me?
Oh no, unfortunately, Ishan is not was not able to make the meeting today.
Okay.
Oh, sorry. No, I have it. Let me just put it up for you. Sorry about that. Oh, I see John. John, are you good to go?
Yeah.
I'm back, Mishuki. Thanks.
Okay. Right. Modus and Samba. So let's have John go since he's back on, and then we'll have you after.
Okay.
John, I'm handing you over the presentation so you can move the slides from.
Okay. Right. Can everyone hear me? Michuki?
Yes, we can hear you.
Okay. So you still have the ball.
Seems to be taking forever to give it to you. All right.
Okay.
Please proceed. I'll move the slide for you as it decides whether it's going to hand over to you or not.
It's fine. So my name is John Gitawa. I formerly worked at Safaricom. Hold on a second. Looks like we have something. No, not yet. So currently, I'm an independent consultant working with I think 2 ISPs and a couple of enterprises and the community at large on technical issues. IPv6 has not really. Sorry, IPv6 has been something I've been working on for a while. And one of the few things I did while at Safaricom was play around with IPv6. I think I made a presentation at the last AFRINIC in Tanzania on the same. So today we'll discuss the same thing. Well, or rather, I'll discuss the same thing with a focus on how they're addressing and exactly what changes you need to make on a mobile network. What you'll realize is the core remains the same. If you're running an MPLS network, your 6PE works without any problem. If you have any considerations for, let's say, a data center those considerations are made in the larger scale. So basically, what Frank has discussed and what Mukom has discussed also applies to mobile networks as far as being a service provider is concerned. Michuki, the ball is taking forever. Tell you what, can you load the slide? You have my slides, right? Michuki? Hello? Hello?
Yes, John, I can hear you good. This is Frank.
Okay. What I'm trying to say, if the ball can be shared with me, Michuki, you have my slides. Can you load them? Okay, so before Michuki manages to pass the ball to me, and before I'll load the slides. Michuki, if you can hear me, you can just load the slides. The main growth driver for mobile network, apart from the fact that there is this whole IP address pool exhaustion, there is also the fact that mobile phones, well, that's where the real growth is. There's quite a lot of smart devices and smart services running on these phones. Traditionally, what you would get with a cell phone was it would connect, like your traditional dial-up. It would connect in, you would get an IP address, pick your mail, or go to whatever site you wanted to go to, and then disconnect. So IP addresses were not such a big deal back then. But today they have to face this challenge where, for starters, mobile phones and all these mobile devices are coming on, and they are staying on. They are not disconnecting from the network. So obviously, apart from the IP addressing issue, most cellular network operators basically will be thinking about all these other resources that they need to sustain that particular connection. Now, if you talk of someone like Safaricom is talking of more than, let's say, 1 million subscribers on data, at any one time you can expect maybe 300, 400,000 of them connected. 400,000 IPs, it doesn't sound like much, but if you think of the load it places on the network, it's quite significant. So that's one. Obviously, there are some enterprise customers who, if they are running IPv6 in their data centers for whatever reason, they might want to access that same content by IPv6. And for this, you might need to provision an IPv6 only APN. I'll explain what an APN is as we move along. And then obviously there's the main driver being what everybody else is talking about. You will run out of IPs. Most of the large content providers are running on IP, and a lot of applications going forward will be written with IPv6 in mind. Michuki, I still don't have the ball. Okay, so I'll just continue the other slides. They'll be shared later. So with mobile phones, you have several scenarios that you would be looking at. You would have the standard dual stack user equipment, in which case this would be a phone that gets both an IPv4 and an IPv6 PDP context. This is a phone that can access both IPv4 content and IPv6 content natively. You also have at the moment I've not heard of anyone who's doing it, but you might have a situation where a phone is only able to connect to IPv6. Either way, one of the scenarios would be an IPv6 end user connecting to an IPv6 node through an IPv6 network. All right. Another scenario we would be looking at is an IPv4 end user connecting to an IPv4 node, in which case, when I say node, I mean IPv4 content, to an IPv6 network. Then you might have a situation where you have an IPv6 phone, as in a phone with an IPv6 PDP content, connecting directly to IPv4 and the reverse. Oh, good, we have the ball. Give me a second, let me share this. Sorry, so we've covered most of this. You have the mobile networking and IP. The RFC to look for the 3GPP network architecture, for those who need to understand the basics, is RFC 3314. And you might have you might also want to look at the transition scenarios documented in 3574. All right. Then we'll have a look at common problems. Some I have already mentioned, and we'll conclude my presentation. So the main growth drivers, like I said, the major one is this one here, and then we obviously have to think of the scenario I had mentioned earlier, where you have some enterprise customers. If I was to give a good example, is banks. A couple of banks in Kenya, for instance, request for what they would call an APN. This is just traffic being backhauls from an ATM to their enterprise data center, whatever it may be. Now, obviously, if an application is running over IPv6, trying to NAT that on the core network for them to access that content might be unacceptable. It might actually break a few things. So in this case, we see a situation where those customers will specifically need IPv6. And don't forget that these customers might not be in Kenya. It could be someone in Asia who wants to run a service of a mobile network, or for mobile users in Kenya. Think of that, since these slides are more in the context of mobile networks, think of that when you think of enterprise customers, at least as far as these slides are concerned. Sorry. One second. Okay. Then you have these are the common scenarios I was going through. This slide should be shared, so you can have a look at this later. But the most common one, and the one you'll hear a lot of people discussing, this whole dual stack. Will be dual stack, and then if you want to think of another dual stack will be very popular, then you have the IPv6 end user connecting to an IPv6 node through an IPv4 network. If you are to draw a small cloud, you'd have this IPv6 node being the content that the user is accessing, and your network being your current IPv4 network, which is exactly what you have right now for most of you. Then you have this case here where you have an IPv4 end user who is connecting to an IPv4 node through an IPv6 network. I think so far the biggest case of the reverse of this I've had is I think Comcast. In their case, it's the reverse, where they have an IPv6 network accessing an IPv6 node through an IPv the reverse, using an IPv6 network. All right, so this is a brief architecture of what the 3GPP network would be looking like. So basically, the phone, we work with channels basically, and that makes it so much easier to deal with. And if you think about this whole tunneling scenario, you realize how easy it makes it. For instance, so the user has a GTP tunnel for his traffic, trying to access some application, and in this case, the transport network and the actual control signal and the data network can be totally different. I.e., you can run IPv4 here while the user here is doing IPv6. This whole area here can remain totally unaffected. The core network should ideally be IPv6 ready. In our case, we were running an IPv6 ready MPLS core, so this was not really a problem. On the next slide, I'll explain exactly what changes. Again, for the guys doing content and the whole IPv4 internet versus IPv6 internet, for this slide, that doesn't matter much to us, but the user here would be coming from either of the scenarios we had discussed earlier. In our case, we'll be looking at a mobile phone that's able to have both PDP contexts running in parallel. Yeah, some phones are not able to run that together. So what you'd have is when you need to access IPv4 content here, it creates a new bearer, and when you're trying to access IPv6, it creates a totally separate one. And the guys from mobile networks here will explain, or maybe can attest to the fact that this is quite a huge load on some of the network elements here. Yeah. All right. So just to show you exactly what changes on the mobile network. First, you need a phone, obviously. So you need a phone that can do either IPv6 on its own, or it can run IPv6 and IPv4 at the same time. On the radio network, nothing really changes here, unless you're changing it for other things. For this particular purpose, you don't need to change anything. On the GSM, we have to load an IPv6 on user plane license. For this, you need to work with your vendor, whoever that may be. So you're looking at either Ericsson, Huawei, or Nokia Siemens. All of them, I know, support these features. Most of the people I spoke to from Europe when we were doing most of these things were running on NSN, that is Nokia Siemens. A couple of guys were running on Ericsson, and in our case, we made the test on Huawei. On the HLR, you need to create a new subscriber PDP that needs to be activated as IPv6. I have a screenshot of this on the next slide, so don't worry. The IP core here, well, this on the service provider core, there are various ways on your core you can run IPv6. If you are asking for advice, I would say go for MPLS. It requires the least work to get IPv6 working. It might take a little work to get MPLS working, but for sure, enabling IPv6 on an MPLS enabled core is nothing. On the other hand, you can just go native. On the GGSN, you need to allocate IPv6 addresses on a test v6 APN pool, but you can choose to do static IP addressing allocation here, especially if you're just running a test for a few users and don't feel like making many changes here. But either way, you need to provision an APN here that's capable of handling IPv6. The other one you need is obviously DNS. You need to be able to run DNS, and in our case, since you are running DNS 624 and not 64, then you need those two elements here. In our case, the only changes we did to looking at this, you realize how easy it is to make IPv6 work on a mobile core, on a small scale. You just need to get this license here, enable it here, create these two elements. I will show you exactly what we used on the next slide. And obviously, your HLR needs to be able to activate this PDP context. Most of the new ones will do it right out of the box. All right. So when I set up a PDP context, two will be created. You have an IPv4 PDP context here, and you have an IPv6 PDP context. Now, normally a network will give you the PDP context, some QoS parameters, if any has been set, and for these purposes, actually, you can use either HTTP proxy or you can use NAT64 and DNS or the or DNS 64. Now, the components used here, we used Tiger for NAT64. It was the easiest thing to play around with at the time. There are other implementations that you can use. This here, for the GGSN, this is what you are running, and then you have the SGSN, and the HLR was running on NSN's base code. The next thing so what does it take to activate bearer here, a dual stack bearer? You just need an internet access point that can be configured as IPv4, IPv4 only, or IPv6 only. There are some, now this, I'm here to see one that actually works this way here, but what you have a lot of is ones that do IPv4 only and or IPv6 only separately. What I mean by this is, I think those are 3GPP recommendations to have IPv4, one PDP context that can do both of these. It saves a lot on resources, and it's the best case scenario in this particular situation. When you configure such a PDP context, if both the handset and the network support this bearer, then it will be used. Yeah, and you won't, for most of the users, actually no change. You should not notice anything. Otherwise, what you'll get is a parallel IPv4 and an IPv6 bearer being used. Then there was, I don't know what to bring. This is just something you need to go have a look at, but on release 10, they're hoping to have something called prefix delegation. This is mainly to support LTE and the fact that a lot of people will actually even now use mobile phones and mobile devices to, as a host for other devices in the network. In this case, it could be my iPad being tethered or Android and all these others. Yeah, you need parallel bearers when an SGSN downgrades your request to IPv4, or if the network knows that you might be handed over to a network that won't be supporting IPv4, v6 type of bearer. Sometimes it happens that on the same network, for a couple of guys I spoke to, that you don't, even on the same network, you're not running equipment at the same, on the same code base, and it's totally different. So this could happen as well for that reason. Applications see dual stack access. In either case, the network can always reject this and force a single stack bearer to either IPv4 or IPv6. And when IPv6 only is configured, it only falls back to IPv4 in case of a roaming network. Remember, if you're running that 6 to 4, then when you're just using IPv6, everything just works, on IPv6. The IPv4 PDP will you don't probably even need to activate it, and that saves you, one PDP context, and that's a good thing for most of these guys. So here I'm showing you an example number that was provisioned with PDP context. So this would be the address. In this case, you're just giving it statically, and obviously based on this, you can see that we don't have the option to have a PDP v4 and 6. You can only have separate ones. In this case, this was an APN specifically that gives you an IPv6 address. All right. Most of the other parameters are just parameters. You don't need to deal with them. If you have any questions, just keep them for the end. I don't think I can even see the chat screen at the moment. So the addressing rules apply for mobile operators the same way Frank and Mukom explained. In this case, if you have a DGSN, just allocate a /64 to it. Every mobile device, just like since you are allocating a /64 for each link, each device would get a /64. If you go by the numbers, this is not really a problem at the moment. Sorry, the requirements for if we get DHCP PD, then life becomes much easier, because what will definitely happen if you try to give users, for instance, a single IP address as opposed to multiple IP addresses that they can use behind their mobile devices, most of them will try and start doing bad things with NAT, just to get their devices to work. So we definitely need to think of how we can allow users to let me call it root through their mobile devices. Then keep your addresses aggregatable within scope or region, and obviously this is planning that goes, it will be planned in context or in the same line of thinking with the other planning that you're carrying on for your enterprise, for your data customers, for your data centers, everyone. And since most of these guys are also service providers, I'll say the same thing, but in this, what you apply for, obviously, like everybody has been saying, make your own judgment, make the decision, and apply. Don't apply for a few IPs and try to get more. Make a full plan and get the number of IP addresses you need. This applies as well for each residential customer with a CPE. The thing to note here, and there's a direct parallel between this line here and this one here. They're still a customer. So if you are going to give each customer another /64 for their home use, it also makes sense that on the mobile devices, I mean, I've seen routers that have GSM modules, for instance, then they will still need a /64 for their use. If you feel this is too much or too little, you can obviously sub-allocate it to either this or this. You decide. Then you also have the fact that you need to do for any business customer, and in this case, you could call it a region or a POP, give them a /48. That should be enough to, for them to resubnet and do whatever they need to do it. And this I had already mentioned. So the biggest problem, obviously, the tests that we are talking about here, even while I was at Safaricom, were done by 2 people. Sorry, they were just done by about 2 people. So here we need more user experience to help identify any issues that might come up. Then another big one is we have a lot of dependency on all handsets, and even internally, I mean, a lot of the engineering teams might understand what needs to be done, but we have very low knowledge within this, especially most of these mobile companies. You have to realize these guys have just come from thinking about packet switching, then they are being told, okay, all of a sudden they have to do IPv4 with packet switching, and before they're even comfortable with what's going on, you're telling them, wait, what you know now is pretty much not useless, but you need to go into IPv6. So there is a huge learning curve for some of these things. Then obviously we have various systems that will be slow to catch up. For instance, billing and charging, packet inspection, if you have a PCRF, and the network management. So in the end, I would just say that channels definitely make it very, very easy for you to deal with your standard 3GPP network. LTE, in fact, comes with everything done with IPv6 out of the box. I noticed DNS is something that's easy to overlook, but it's very important with IPv6. Start with the core. It helps if your core is ready for IPv6 in one way or another. Having IPv6 only bearer definitely makes a lot more sense as far as the resource utilization is concerned. Since all of us seem to be looking at what other people have done, the local carriers really do need to come up with their own strategies for how to deal with this, how they do the addressing, all these things. They can ask for advice, but in the end, they have to make those decisions themselves. The last conversation I had with someone was, I mean, why would I do IPv6 when nobody is really using it? And my argument was, if you are to turn on IPv6 today, if Google and Facebook and Yahoo is more than 50% of your traffic, you can be guaranteed that 50% of your internet will be on IPv6. So really something to think about. And of course, there's a fact that you need to ask for help if and when you need it. All right, that should be it.
Okay, thanks very much, John. Yeah, thanks very much. So the last presentation is going to be by Samba, and let me share his presentation. Okay. All right. Can you hear me?
Yeah.
All right. It's taking forever again. I think I have a serious problem with my Java. Someone, could you?
Yep, I'm here. I'm here.
Could you help again?
Who should I pass the ball to?
No. I'm saying it takes forever. I do it, but it takes forever. Like,
Okay, who do you want me to pass the ball to?
Samba Tiam.
Samba Tiam. Okay, I can see him. Just give me a...
Yep.
Done. Samba, you're on.
I'm sure you have to share your screen. You could do that. Just open the PowerPoint and share your screen.
Okay, you see the presentation? How?
Yes.
Do you see the presentation?
Yes, Samba, we can hear you.
Okay, you see the presentation?
Yes, we do.
Okay, so we will quickly present the VPN basics addressing strategy of Sonatel, because now we have we are testing the VPN basics technology, and in the near future we will test ADSL basics. So in this presentation we will only talk about VPN. So we will see the two parts of the presentation. The first is addressing plan for the backbone, and the second is some security rules we deploy in our VPN basics services. Some remind about addressing plan in IPv6. The addressing planning in IPv6 is simpler than in IPv4 because we have some mechanisms like automatic addressing, etc. So the best practice is to first identify your networks that require special security or quality of service policies and assign different prefixes to that network. So once the network are identified, you will need to decide to use automatic or manual addressing. Automatic addressing is simpler than manual addressing. If I can give an example, you can use automatic addressing for desktop machine or some subnet and use static address for some specific node in the network like firewall, routers, and some servers. And regarding the address allocation in RFC 30,170 recommend that in each site should be addressed /48 from the /23 address block received from the rear. Another IOTF recommendation encourage to assign /64 to every subnet within a site to the 6045 prefix per se. So we give this image to explain what I am telling later before. So in the next slide, we give some engineering rules of addressing plan for our MPLS VPN services. We have some loopback addresses for the MP IPVGP session between peer v6 vPeer and IPv6 root reflector. Just to remind, in VPN v6 or 6 vPeer, we have some node like in IPv4 we call provider edge router or customer edge router in the customer side and peer router in the core network side. So the rule we are using in our network is to have an IPv4 loopback address in the PS side, and we configure also a loopback address on each new dedicated IPv6 root reflector for primary and secondary meshing on Sonatel network. For peer and CR access, some customer sites today IPv4 will require also to exchange IPv6 traffic. In a such case, customer need CR customer edge needs to support dual stack. That means the customer edge router have to support IPv4 and IPv6. For IPv4, the PE and CE link requires the allocation of /30 subnet. The best practice being also follow. All PE and CE to be configured must provide with a /80 subnet. IP address used on PE and CE links play a local role. They should not be advertised anywhere. So they just play a local role, not to be conflicted with some customer internal addressing. So the traffic between the addresses should be limited to the link between customer edge and provider edge router. So in the address plan for MPLS VPN services, IP address should be picked up in the RFC 1914 private range on a per customer basis. IP address should not be conflicted with customer internal address, like I said before. So for IPv6, the PE to see a link record /64 subnet. You see that in the IPv4 it was /30. In the IPv6 we have /64 to be compliant with the standardization and avoid any compatibility issues for the future. And all the provider edge and customer edge interface have to be configured to provide with a /64 subnet. IP addresses use of a PE and CE links play a local role only. It's the same done in IPv4 and then IPv4, and they should not be advertised anywhere. The main difference is that IPv6 address could be local link address, unique local address, or global address taken in the Orange Senegal range, and we have a /32 IPv6 address, which is given to us by AFRINIC. So it's the main difference between IPv4 and IPv6. We can have a lot of level of addressing, link local addressing, unique local addressing, and global addressing, and depending to the visibility we want, we can use one of their type of address. Today, global address seem to be the preferred choice, but final decision is not taken yet, and it's not possible that for future use we have to reconsider the usage of local link address or unique local address. The /64 subnet may to be recorded in the provisioning tool for a matter of provisioning and traceability of the address we are allocating. IP address should not be conflicted with customer internal addressing. Some security rules specific to IPv6 we have in this IPVPN with IPv6 is, for example, unicast reverse path forwarding for added protection against network spoofing attacks. This RPF basics help to prevent traffic spoofing by identifying traffic coming in on an unexpected an unexpected port. This is required, for example, for DSL architecture. The routing header for the routing header, we use the same rules as in IPv4. It has to be blocked. Now IPv6 source rule. We use some other techniques like IPv6 fragmentation, like also NGP or like DHCP. And for the security of router access, we use Telnet and SSHD are dual stack and can be secured by specific access control list. So we should update the standard VTY access control list for IPv4 to deny any for IPv6. So this is a brief explanation of our architecture of addressing we use in our VPN services on and some security rules. Thank you for.
All right. Thank you very much, Samba. We have indeed gone through very interesting presentations. Thanks again to all the speakers. Unfortunately, because of the technical issues, we are running 15 minutes, 12 minutes late from when we were to end the call. But I think if everybody is in agreement, we can allow about 15 minutes of discussions, questions and answers with the panelists. And if that's okay, I'll be happy to take questions. If you look at the screen, the WebEx screen, you should see a small hand just below the list of participants. So if you could raise that, if you have a question, and then I'll call on your name and you can ask the question. Is that clear? So if you do have a question, please click on the hand, and it will come up as somebody who has a question. And Kevin, you will be able to see the names, and I think I'll need to become the host to be able to see the names. So let me take that from you right now. Okay. So I don't see any hands. Okay. Someone has a question. Go ahead, someone. Someone go ahead. Someone.
Can you hear me now?
Yes.
Okay, my question goes to Mr. Habib. During his presentation, he did mention that he uses /112 for his inter-device links. Could he explain a bit more why he chose that particular prefix length and not some of the other recommendations we see, like /120, etc.? Why /112?
Hello, I hope you can hear me.
I can hear you.
You can?
I can hear you.
But it's basically very conservative. It gives space for 65,536 addresses, and that will be enough for a link to a customer. And I agree with the others that it is a prudent, a good move to reserve more in case something new comes up in the future.
Okay.
But basically, it seems to be enough space, and we can have many, many more links in the finite address space that it is, because it's not endless. And we hope to have more customers, everybody of us. So I of course also try to avoid a /64 as such, because then if somebody doesn't disable it, you have automatic address configuration that takes matters in its own hand. And we have mainly corporate and big customers that will use static IP configuration anyway. So we want to have that control that the addresses on the link don't get automatically configured. But as to why not a /80 but a /112, just so that we can have more links. But it's everybody can do their own stuff. It's not that this is the best. Absolutely.
Thank you.
Okay.
All right. Any other questions? I'm not seeing any other questions. So does that mean the topic is clear? And I think I do have a question here to all the presenters. What is the recommended, or what would you recommend for people to look at when doing this, allocating to the end user site? Is it a /64? Is it a /48? I've seen varying numbers, /48, /64. What do you recommend, especially for ISPs?
Okay, can I go?
Sure.
Okay, for the end user, there's several classes of end user. There's a single, what we'll call the SOHO, or I'll classify them. The end user is the individual who has an ADSL and connects just for home use. There's a SOHO company, small company with a single LAN, and then there's the enterprise. So for the smaller guys, the very least says that at the very least, when you in the situation where today we'll assign a /32 point-to-point, you should give at least a /64 so that they have one prefix that they can use on their LAN for whatever purpose. And remember that this /64 is in addition to the address that you're going to assign to the connection between you and the CPE, between the ISP and the CPE. For smaller networks, anything say a /60, which is consistent with working along bit boundaries, is recommended from what I've been reading and hearing other people discuss. And then, of course, for larger end users that are ISP enterprise class end users, is /48. So, in summary, if it's someone you're sure, it's maybe like the case of the mobile device that's going to be tethered, assign it /64. If it's a small office home user which is going to have more than one subnet, say assign maybe a /60, and for an enterprise, /48. These are in addition to the addresses that you're going to assign to their one site. That's all from my side.
Right. So this is John. I think I'm looking at it. When we look at the core network, and specifically for And then when you look at core networks in relation to CPE, there is a link that obviously connects towards the CPE, and then what tends to happen is, in most cases, you have customers with their own networks at the back there. Sometimes it could be a home user. I'll give you an example of me. If I came to you for a link and I ask for IPv6, I will definitely want another set of IP addresses to use for my devices. So if I'm looking at it this way, at least as far as I'm concerned, I would say go with /64 everywhere, for the simple reason that stateless auto configuration only works on /64. That's a limitation you need to consider before you do any of these other allocations. What you can do, for instance, is issue the /64, yes, but like I think Muko mentioned it earlier, when you're doing the actual, when you're adding it to a device, for instance, you can make it a /120 if you want. The other thing to note here is there are some security issues you need to consider. Most ASIC-based layer 3 devices, if you're running like I think a Cisco switch, they're all vulnerable to IPv6 neighbor discovery, I think an exhaustion attack. Someone mentioned earlier how they would go about that. But since the number is so large, this can affect you more than it would affect someone being affected by a simple app attack. So at least as far as I would, if I was asked to subnet a network today, I would say any network that you need stateless auto configuration, you have to use /64. For like data centers or any of these customers who are just running such like networks, a /120, probably carved out of a /64 is what I would go with. And then I would have DHCPv6 server assigned addresses in this case. Point-to-point links, I would go with /127. And if I'm pushing this all the way, I would have /128 for loopback addresses. I think Juniper have a new RFC with this recommendation. I'll try and get it out before this call is over. The only thing I would also add is it should work, but I would suggest you test. A lot of things really have been hardwired with /64 in there.
Yes. Very important.
That's it.
Thanks. Any other, Frank, do you have a comment? Samba?
Echo. Sorry. For exhausting the neighbor discovery spaces, it's surely a benefit if you have a small subnet like a /112. Of course, I also chose that specific number because it exactly covers the last field after the last column to have the host address, and everything before the last column is the subnet address. But then if it's a smaller network, then somebody from outside will have it more difficult to exhaust the neighbor discovery cache. For loopbacks 128, there's actually no doubt in my mind. And when assigning /64s to customers, I actually would like to caution it's better to assign more if in a well, as long as we are talking about customers that are not getting the assignments dynamically. If it's a static assignment to a residential customer with a /64, I think the likelihood is very high that in the next 2, 3 years or 5 years they will need more, and I think we should avoid it, and we should start by giving them a /56 or something like this. Just give them more than they need already, so that it doesn't need to be changed later. That's from my side.
Yes, you're right. Obviously, you would have to give whatever the customers require, but you'll find a lot of guys, for instance, there are customers who need multi-subnet allocations at /56. Makes sense, but there are some customers. If you think of a customer behind a mobile device, for instance, so I think you're right. It depends on what kind of customer and why you might want to go that way.
Okay. So
Yes,
I
this
see
is
a similar question on that from Mahmoud Ali on the chat room, where he's asking, so if they provide a /48 to each enterprise, then which will only support about 65,000 subnets, should they change their subnetting so that they have /48, /52, and /56, or what's the best practice?
Should I say?
Yes, please go ahead.
Okay, this is Frank, and I would say it depends on what kind of a network, what kind of an operator that is. If it's just a mobile network, then I agree to what John just said. A /64 for a mobile device is fine. If it's a network, a provider that has mainly enterprise customers, then most of the assignments should be /48, and that should be the bulk of the assignments. And maybe if they are DSL customers, lots of them, then /52, /56 makes a lot of sense. And if it's a mixture, one has to weigh whether one should have the complexity of having different assignment sizes, or whether one should make it all /48. That could be a policy, a valid policy, and it's just a policy decision that has to be made.
I would say that if you are actually concerned about the need to be able to aggregate, it makes sense. You see, for a specific customer, you can say, fine, even though I'm reserving this /60 for you, I'm only giving you a /64 out of that. Should that customer come back in the future and want more, you can always give them a contiguous range from what you reserve for them. As for going back to the question that Michuki just posted, if the customer is large enough, say like a university campus, I would suggest that they not try to, or you the ISP, not try to fit them into a /48. Let them make an address plan, and then you give them what it is they require. It could possibly be that you have to give 2 contiguous /48. But just like we are recommending that ISPs, because AFRINIC has policy that says we give everyone at least a /32. ISPs should not fit themselves to a /42. For large enterprise networks, we shouldn't try to force them to fit into /48 as so. They should also do proper address planning for their enterprise networks and then make that request from the ISP, which might find that fine. If it goes above the limit, if the ISP has a policy saying for large enterprises you're giving /48, and the enterprise comes with needs that exceed that /48, then you could say fine, I'm going to give you 2 contiguous 2 /48 that are close to each other. So I think it should go back again to, we should give people what it is they actually say they need. But of course, for really small cases, you can pretty much say, okay, the person who's going to tether an iPhone or an iPad doesn't want multiple subnets. So that is almost pretty straightforward, the /64 for them.
Okay. All right. So, Com, you had a question, or that was just for that particular comment?
Yes, I had a question that goes to Frank and John, who've been testing. On a couple of fora online, you've seen people report that whenever they used /128 for their loopback addressing, it caused routing performance issues. Specifically, that their routing platform started doing process switching rather than the hardware optimizations. Have you guys experienced any of that?
This is John. So the disclaimer with this whole /127 and /128 is you have to test it. Whether you use hardware or software switching is actually, it's more for everything. Think about firewalls. one of the biggest issues we'll have with firewalls is you have this, there is no fixed position to say UDP is at this position, like we had with IPv4, for instance. So what you have is, it's very hard to make a firewall work specifically at at wire speed or on hardware. The same way with /128, most of the issues, I know I've seen a lot of people having some of those same issues. Personally, I've not tested enough to say that I have experienced these problems. But you're right, fun, interesting scenarios might come up. We just need to document them. And if your network is actually affected by this, then you will change. So say test before you actually deploy on your entire core network or whatever.
Thank you, John. Which again, okay, that what I'll point out is that, and this is where it's important to, if you had previously allocated a /64 for that loopback, and then it turns out that you have to change, then you don't have to renumber your whole network. So you might allocate that /64 and then configure the 128, the 127, and then if you have problems, switch it to /64 and you won't have problems. But if you are not planned to have allocated that /64 before, then you now get into the terrible situation of having to renumber your network. Thank you for that clarification.
All right. So there's a question for you, Tamon. Initially, AFRINIC handed out /32s to everyone. Did they leave space for expansion? If I now can motivate for a /24, or would it mean additional address space?
Right now, the AFRINIC policy is, okay, the /32 is actually a policy requirement. The policy says that the least address space that an LIR can request for is a /32. Now, whenever you do that, our host master, registration services, they always leave the adjacent of whatever you requested for. So that if you want to expand, they can give you space which is really adjacent to what the block that you originally requested for. So, for example, if you requested a /28, what the host masters will do behind is that the /28 that is immediately adjacent to you, they'll just keep it. They won't allocate it to anyone. So that in the future, if you come back, you can get address space that's contiguous to what you initially requested. Does that answer the question?
I believe so. Well, I think we've really run out of time. We were scheduled to end this at least 5:30. We've gone over by slightly over 30 minutes. What I would suggest is that you've seen, we will post up all the presentations. We have all the email addresses of the panelists today, and basically, if you have any questions you would like to direct them, please feel free to do so. Also, you can write to us and let us know what we can do to make it better. We do have a questionnaire that is ready. We will be sending it to you for all of those who registered. We'll send it to you shortly after the end of this call. And basically, we'll appreciate if you could actually fill it in. Just about 6 or 7 questions, should take you about 5 minutes. And so that we can be able to know what topics to plan for the next IPv6 webinar, what topics might be of interest to you, and also help us get the right speakers as well. And also anything else that we can help to, or rather any other comments that you would have to help us improve on this presentation and these sessions. We do sincerely apologize for the technical problems we've had today. They seem to be a bit worse than the very first one, partly because of infrastructure and services for where most of the hosts are located. But we do hope that you got to pick 1 or 2 things from the session. So with that, I'd like to bring this webinar to an end. Thank you very much for taking the time to attend, and we hope that you'll be able to join us at the next one. As we had mentioned, we plan to make this monthly event, and so we will be announcing the next IPv6 webinar, which will be in May, most likely towards the end. So thank you very much to our panelists, Samba, Frank Habich, John Gitau, and Mukon Tamon from AFRINIC. and look forward to talking to you at the next one. Thank you very much.
Thank you very much, Michu. Thank you everyone for listening. Bye-bye.
Okay, bye-bye.